Now we shall look at the applications of dot product. In the last video we saw that the dot product between two vectors is written as A dot B, and by definition it is given by AB cos theta. It is also given as another expression which is AX BX plus AY BY plus AZ BZ, and we use this expression when we have the two vectors in their rectangular component form. Now we shall look at where we use a dot product. Okay, so the first application of dot product is to identify whether two vectors are perpendicular to each other or not. We have already seen that if two vectors are perpendicular, if vector A is perpendicular to vector B, which means the angle between them is 90 degrees, the dot product between the two vectors is equal to 0. A dot B is equal to 0. So this particular result can be used to check whether two vectors are perpendicular to each other or not. So if two vectors are given to you in their component form, you just find out their dot product to see if it is coming out to be 0, to check whether the two vectors are perpendicular. Second application that we have for dot product is to find out the angle between two vectors. To find angle between two vectors. How do we do that? If we have a vector A and a vector B, and we are supposed to find out the angle between them, we can use the basic definition of the dot product, which is A dot B is equal to AB cos theta, and from here we can write the expression for cos theta by taking the term AB on the other side, and that gives us cos theta is equal to A dot B divided by A into B. So if we just divide the dot product of a vector of two vectors by the product of their magnitudes, we will get the cos of the angle between the two vectors. This is an important relation. We use it quite often to calculate the angle between vectors. The third application of dot product is to find the projection of a vector along another vector. To find projection of a vector along another vector. Now what is a projection? Projection is nothing but component. This is another name for component. The only difference is when we usually find out component of a vector, we find it out along a standard direction. For example, along the x-axis, when we try to find out the component of vector A, it is given by A cos theta, isn't it? This particular length is the component of vector A along the x-axis. Similarly, when we find it out along the y-axis, it is A sin theta, the component of vector A along the y-axis. In this case, we try to find out the component of vector A not about any standard axis, but about another vector, which is, let's say, vector B, with which the vector A makes a certain angle theta, and that angle is given to us. Okay, even if it is not, if we know the two vectors in their component form, maybe we can find out the projection of vector A along B or B along A. Now the method of finding out the projection, which is nothing but component itself, just that it is now along another vector instead of being along a standard direction, the method of finding the component would be the same. So for example, if we have to find out the component of vector A along vector B, we will start by dropping a perpendicular from the tip of vector A onto the vector B like this, and then we will try to find out this length. From the figure, if you look at this carefully, this right angle triangle that we are getting, the component of A along the vector B, this length is nothing but, this particular length is nothing but A cos theta, isn't it? Component of vector A along vector B by definition is A cos theta. And how do we get the value of this A cos theta? For finding out this value, we take the definition of dot product. Now from dot product, we know that A dot B is equal to AB cos theta. Now from this relation, if I am supposed to find out the value of A cos theta, what I can do is I can take B on the other side of the relation, so that we get B, not B here, A cos theta on the right hand side is equal to A dot B by modulus of B. So A cos theta, which is nothing but the component of vector A along vector B, is now having an expression. We can use this particular formula to find out the component of A along vector B. This will be easier if you have the two vectors in the rectangular component form. It will be easy to find out the dot product, and you can easily find out the magnitude of vector B and get its value and substitute it here in this expression. Understand that on the same lines, we can also find out the component of vector B along vector A. Component of vector B along vector A, for which we will use the same method. If we go back to the figure, to find out the component of B along A, we will be dropping a perpendicular from the tip of B onto the vector A. This is the right angle triangle that we will get, and this is then the length of the component of vector B along vector A, which by definition will be B cos theta. So B cos theta is the component of B along A, and we can get the value of B cos theta from the same expression of dot product from A dot B is equal to AB cos theta. Now we can find out the value of B cos theta as A dot B by mod of A, modulus of vector A. So this becomes the relation for component of vector B along vector A. So see that using dot product, we can find out the component, or what we call as projection, of a vector along another vector. We can look at a few examples based upon these three applications that we have just now discussed. First example could be, let's say vector A is given as 2i cap plus 3j cap, and vector B is given as xi cap minus 2j cap. And the question is, find x for which vector A is perpendicular to vector B. We have to find out the value of x for which vector A and vector B are perpendicular to each other. So we know that for A and B to be perpendicular to each other, if A is perpendicular to B, that means their dot product is 0. So A dot B should be 0. Now from the above relation, we know that A dot B is equal to AX BX plus AY BY. That should be equal to 0. So when we substitute the values, AX here is 2 and AY is 3, BX is X and BY is minus 2. So we will substitute the values, 2 into X plus 3 into minus 2, this should be 0, and we can solve this easily to get the value of X as 3. As another example, where we try to find out the angle between two vectors, let us have vector A, which is given by I cap plus 2j cap, and vector B, which is given by 2i cap minus j cap, minus 2j cap, let us take it. In that case, if we are supposed to find angle between vectors A and B, we can use the application of dot product. We can say that cos theta is equal to A dot B by mod of A into mod of B. This expression will give us cos of the angle between the two vectors. A dot B we can find out by using the expression AX BX plus AY BY divided by magnitude of vectors A and B. We can calculate from AX squared plus AY squared whole square root. This will be the magnitude of vector A, and BX squared plus BY squared will be whole square root will be the magnitude of vector B. So we can substitute all the values now. AX is 1, bx is 2 plus ay is 2, by is minus 2 divided by magnitude of a, which will be square root of 1 squared plus 2 squared, which is 4, into square root of magnitude of b, which is square root of 2 squared, which is 4, plus square of minus 2, which is also 4. So when we solve this, we will get 2 minus 4, which is a minus 2 up here, divided by square root of 5 into square root of 8. Square root of 8, maybe we can simplify and write it as 2 root 2. So we will have minus 2 divided by root 5 into 2 root 2, and the 2 will cancel out, and we will be left with minus 1 by root 10. And from here we can say cos theta, this is the value of cos theta that we have obtained. From here we can say that theta will be cos inverse of minus 1 by 10. This is how we write an answer for the value of theta in case we do not know the angle corresponding to a certain value of a trigonometric ratio. If this value is not a standard value, then we can always write the angle in this particular form, right? Can you tell me what does the minus sign imply here for cos theta? Cos theta we all know is negative in the second quadrant when the angle is obtuse. So this minus sign is telling us that the angle between the vectors a and b is an obtuse angle.